Okay. Is this not recording now? Oh, it is recording. There we go. I'm sorry. Oh, well, I started this one differently. How about that? That's nice. Okay, guys. Now, when you look at the terms, we've got 4 terms. Okay? But these terms have variables with powers of 2 in them. Okay? When they have variables that are raised to a higher power than just 1, when they go to squared, we're most likely going to use 1 and 3. Now let me ask you something. I want you to look at these. One of these things is not like the other. You played that Sesame Street game. I'm not going to sing the song for you now, but one of these things is not like the other. Okay, good. I did. I said I wasn't, and then I lied. But that's what I do. That's what I do. I kind of send you one way and then pull you back the other, right? Okay, now here's the thing. The thing that's not like the others is that one. Okay? And here's why. This one has q squared, qr, and then r squared. This looks just like one. If I cover this one up, right? If I just cover this up, this looks like ones that we've done for homework, right? I know how to factor that. That's good. I want to group it into something that I know how to factor. And I know how to factor that. I'm going to use the quadratic formula. Okay? But now, what I have to do is this. I'm going to put up some parentheses here, but wait a minute. What just happened to that 4q squared? What happened, CB?
You cut out the negative, which makes it a -1, multiplying and changing.
Exactly. All those signs have to change. That negative 4q squared is now a positive 4q squared. So I have to rewrite this as 4p squared minus parentheses 4q squared minus 4qr plus r squared. Okay? Now, you might see that this is a perfect square and that's a perfect square. That was section 5.6. And you remember we asked those questions? We said, hey, is this a perfect square? Yeah, it's 2q. Is this a perfect square? Yeah, it's r. Is the middle number, or negative r, is the middle number 2 times a times b? Is it? Okay, well 2q times negative r is negative 2qr. And then when you double it, you get negative 4qr. So this is a perfect square. 4p squared minus parentheses 2q minus r squared. That's section 5.6. Good. Am I done? No. Why am I not done? Who sees what this is? Who sees what this is, Gordy? It's a difference of 2 squares. It's 2p plus 2q minus r. And then it's times 2p minus 2q minus r. Wait a minute. Why did I put that 2q minus r in parentheses but not the first one? Why did I do that, Miles?
Because if you didn't, then the r would be squared as well.
No. Why did I put this one back here in parentheses? Because it's minus. I've got to make sure that that gets distributed. It's going to be 2p plus 2q minus r times 2p minus 2q plus r. It's getting pretty sick, isn't it? All right. Now, guys, what if it wasn't a perfect square? What would I have done when I'm up here? What if this trinomial was not a perfect square? What would I do, Benny? How would I factor it if it was not a perfect square? Not you, Reuben. What would Benny do? No, I wouldn't undistribute. What's that, CB? Quadratic formula. Work backwards. All right. Good job, guys. You're learning. This is what learning's called. It's painful.